So if we did a significance test for the difference, remember, again, the difference is equal to the hypothesized value, right? So remember, we always assume that there is no difference. So again, just like with proportions, mu1 is equal to mu2. Remember, this is going to be the notation that I use, is going to be the null is that mu1 equals mu2, which means the alternative is going to be mu1, the alternative is going to be that mu1 is greater than mu2, or that mu1 is less than mu2, or that mu1 is not equal to mu2. Okay, so these are going to be the format that I use, but remember, we always assume that they're equal because we're assuming that there's no difference. Okay, so again, here's our formula, statistic minus parameter over the standard deviation of statistic. So here it is. Well, if we assume that this is, or equal, remember this is always going to be 0. So that's going to become 0, so anything minus 0 is just itself. So really it's this over this. That's going to be our statistic here for the difference of 2. All right, define the p-value and use the t-distribution with the degrees freedom given by technology or by the conservative approach. Remember, the smaller of n minus 1 or n minus 2. The following conditions are met. We did that. So the same conditions have to be met. All right, so here's how you find it. Remember, this is not equal to. So if we look at this, here's our example from the calcium and blood pressure. It says, does increasing the amount of calcium in our diet reduce blood pressure? Examination of a large sample of people revealed the relationship between calcium intake and blood pressure. The relationship was strongest for black men. Such observational studies do not establish causation. Researchers therefore designed a randomized comparative experiment that subjects were 21 healthy black men who volunteered to take part in the experiment. They were randomly assigned to 2 groups. 10 men received the calcium supplement for 12 weeks. The control group received a placebo pill that looked identical. The experiment was double-blinded. The response variable is the decrease in systolic top number blood pressure in the subject after 12 weeks in millimeters of mercury. An increase appears as a negative response here in this data. So if it increased, okay, it appears as a negative. So they went ahead and did this, right? These are people with calcium. If it increased, it went as a negative. That's bad. So we really expect, there to be positive because we're hoping that the calcium really does drop it. And here's placebo when they know to take sugar pill. All right. So they look at the dot plot of the 2. All right, mu1, they're going to assume there's no difference in between taking a calcium and a placebo pill. And then our hope is that mu1 minus mu2, that there is an increase. So really, I would write this as mu1 is equal to mu2, and that mu1 is greater than mu2. Because remember, a positive, an increase appears in their blood pressure appears as a negative. So a decrease, remember we want a decrease in the blood pressure, so we want the mean of 1 to have a decrease means it's going to have a higher number. I know that's confusing, but according to the study, they're going to have a higher number if they decrease their blood, which is what we think calcium does to it. So we want the mean of group 1 to be higher than the mean of group 2. And so this is a really confusing problem as far as setting it up, and just know that they'll mess with your brain like that. So they tell you what the mean, what mu1 and mu2 is, like you're supposed to. Alpha is equal to 0.05, and they stated the null. So the plan, there's 21 subjects randomly assigned to the 2 groups, so random is accepted. Normal, with such sample size, we need to examine the data to see if it's reasonable to believe the actual distributions of differences in blood pressure when taking calcium are normal. Hand sketches of calculator box plots and normal probability plots for these are below. So they said they checked the box plot, the normal probability plot for both of them. So you would say, okay, I looked at a box plot, doesn't look to be any real skewness or outliers, and the normal probability plot is decent. Okay, there's no evidence of clear evidence of skewness or outlier. The normal probability plot of the placebo's response looks very linear, while the normal probability plot of the calcium shows some slight curvature with no outliers or clear skewness, so the T procedures are pretty accurate. So remember, because my sample size was small, I had 10 in one and 11 in the other group, I'm going to have to look at this data. And then they're independent because of their random assignment. The two groups of men are viewed as independent. So here's our do step. X bar minus bar 2. So you actually have to find it, right, using the data, or you can run this thing in the calculator from beginning to end. So what you would have done is that you would have put all that data from here in your calculator in a list and spreadsheet right from the beginning as soon as you were given the data. All right, and that's what we're going to do in the next video.